Bismillahirrahmanirrahim. Students, once again I am here to give presentation on the application of the electrochemical cells. Electrochemical cells have vast application in the field of batteries and electrolytic cells. Batteries exist in the form of dry cells, storage cells, and mercury cells. These cells are different from in terms of the composition of batteries and capacity of current. Whereas the electrolytic cells are used for the production of such substances which cannot be prepared easily and economically. That is why the electrolytic cells are used for the production of alkali metals which include the sodium, potassium, rubidium, etc. Furthermore, these electrolytic cells are also used for the production of refined copper from impure copper. Another application of the electrolytic cell is the electroplating, in which one metal is deposited on another metal. When gold is deposited on another metal, then it is called the gold plating. When zinc metal is deposited on another metal, that is called the zinc plating. And when chromium is deposited on another metal, then it is called the chromium plating. Similarly, tin plating. These plating are also named as, for example, zinc plating is also called the galvanizing, chromium plating is also called the chroming, tin plating is also called the tinning. Now come over the function of batteries. Batteries are used for the production of electricity. They are placed in the circuit. When the circuit is connected to the negative terminal of the battery and other part of the circuit is connected to the positive terminal of the battery, the current flows due to the potential difference. That is why the batteries are used for the used to run the electrical appliances like the toys, flashlights, calculators, digital watches, etc. If we see the structure, how it works, then we will come to know that in the battery or in the dry cell, the central part is the cathode, which is made of graphite, whereas the external part is the zinc metal can that act as a anode. The cathode is pasted with the manganese dioxide and charcoal, which is the activated carbon, is placed an electrolyte that consists of ammonium chloride and zinc chloride. At cathode, oxidation takes place. As a result, zinc changes into the zinc ion with the liberation of 2 electrons. And at anode, these 2 electrons are taken up by the ammonium ion and manganese dioxide. As a result, they change into the ammonia and manganese trioxide. That is why the batteries work and generate the electricity. Now, see the functioning of the electrolytic cells. Electrolytic cells are of different types. For example, for the production of sodium metal, we use the Downs cells. The Downs cells consist of a chamber in which the electrode, which is made of graphite, is placed in the center. That electrode is covered with an iron screen. This whole chamber change into the elongated tube. With this chamber, the cathode tube is present. That cathode tube is placed in another chamber where a tube is connected to it, which is linked with the cylinder. At anode, oxidation takes place, and at cathode, reduction takes place. When sodium chloride is introduced into the chamber from the upper entrance, it first changes into the molten sodium chloride. The molten sodium chloride contains the sodium ion and chloride ion. The chloride ion first undergo the oxidation at anode. As a result, chloride ion changes to the chlorine gas, which is exhausted from the tube, whereas sodium ion undergo reduction. We take up the electron from the oxidation and change into the sodium metal. That sodium metal is transferred through tube into the cylinder, where it is drained time to time. Now see another electrolytic cell, that is the Nelson cell. The structure of cathode of Nelson cells is different from the Down cells. In Nelson cell, we produce the caustic soda from the brine, which is a concentrated sodium hydroxide solution. Here, the anode is in the center, which is connected to the positive terminal of the battery, whereas cathode is a U-shaped tube that has perforations. When sodium chloride solution is introduced into the U-shaped chamber, it undergoes oxidation and reduction. This solution contains the sodium ion, chloride ion, and water. The chloride ion undergo oxidation that takes place at anode, which is made of the graphite. As a result, the chlorine is produced, which is exhausted from the chamber, whereas water is reduced and in the chamber and changed into the hydroxyl ion. That hydroxyl ion comes with the sodium ion and pour out from the chamber into the lower vessel that is just behind it, that is just lower it. During this process, hydrogen gas is produced that is exhausted from another tube. Thus, the sodium ion and hydroxyl ion, which is collected at the lower vessel, is evaporated and converted into the sodium hydroxide in solid form, which is taken out from the chamber. Thus, the Nelson cell is used for the production of caustic soda in solid form. Another application in terms of electrolytic cell is the refining of copper that is also carried out in the chamber. Here, the metal is pured. The metal which is impure is act as anode, and the metal which is pure act as a cathode. The solution contains the electrolyte, which is the copper sulfate. The anode melts. As a result, the impurities are settled down in the solution, and copper start melting, which contain the copper ion. That copper ion are deposited on the pure copper cathode after reduction. This process carry on until the whole impure metal is free from impurities and copper. Thus, we obtain the pure copper by the electrolytic process. Electrolytic process can also be used for the electroplating, as I told you earlier. Here, the difference is the metal which is deposited on the other metal, that could be steel or iron, is placed specifically with respect to the metal. In case of the gold plating, the anode would be gold. In case of the zinc plating, the anode would be zinc. And in case of the chromium plating, chromium act as a anode. Similarly, in tin plating, the tin act as a anode. Similarly, the electrolyte will also be changed with respect to the metal which is to be deposited. In case of zinc plating, potassium tetracyanozincate is used. Here, zinc change into the zinc ion, and after melting, which is deposited on the metal, on the iron metal after reduction. Similarly, chromium plating, we use the chromium anode, and the electrolyte would be the chromium sulfate. The chromium is deposited only when it is molten in the solution. Then the molten chromium contain the chromium ion, which undergo the reduction and deposit on the steel, metal or the iron. Similarly, the tin plating, the tin electrode, which is anode, is deposited on the steel metal or iron metal, and the solution contain the tin sulfate. So these electroplating are with respect to the functioning of anode and electrolyte which is used in the cells. Another application of the electrolytic cell is the cathodic protection. The cathodic protection is that protection in which the metal which is to be protected from rust is made cathode, and the active metal is deposited like the magnesium or chromium. This is also one of the application of the electrolytic cells. Thus, the electrochemical cells have vast application in the industry for the generation of electricity as well as for the production of chemical substances which cannot be produced economically. That is the today lecture. Thank you for watching. Goodbye.